running Kruskal's algorithm on a graph is going to result in a minimum spanning tree. And a minimum spanning tree is the minimum weight representation of a graph, meaning that each vertex is included inside our tree, and we're choosing the minimum, the combination of edges, which provides the minimum number when you sum up all the edges. Kruskal's is going to accomplish this using a priority queue that sorts edges, and it's also going to make use of union find data structure. Union find. So what we've done here is we've labeled we have an edge list. So this is just saying that A is connected to B with weight 1. D is connected to F with weight 1. And we have these sorted increasing by weight. So how union find is going to work is it's a set. Each vertex is going to start in its own set. So if I draw, so A is in its own set, B is in its own set, C, D, E, F, G. You notice this is a set of sets. So we have a big set which represents the graph, and then we're going to have a small set which represents connected components, okay, or subtrees within the graph, subgraphs within the graph. So how Kruskal's going to work is I have all my edges sorted, and I'm going to choose the minimum edge each time. So I pull out my A-B edge out of the priority queue, that's one. And how union find is going to work is I can tell if adding this edge, AB, if adding this edge to the current minimum spanning tree, I can tell if it will cause a cycle if these elements are in this. If A and B are in the same set, then it will cause a cycle. However, A and B are not in the same set, so I can add this edge. So if I rewrite, I can only rewrite it a few times, but now A and B are in the same set. C, D, E, F, G. So A and B are now in the same set. They've been added to my minimum spanning tree, and C, D, E, F, and G are all in their own set. They have not been added to the tree yet. So now I pull out the next edge, so D, F. And I can tell that these are not in the same set or these will not cause a cycle because they're in a different set. So if I union these sets together, so D and F are now in the same set, and E, I just swapped places with E. So now A and B are in their own set. This is a connected component, and DF is also in a set. It's a connected component. Okay. So we continue the algorithm, AC with 2. So we're now adding this edge. So C and A are in different sets. They won't cause a cycle. So we'll go and add that edge. We add the next edge, FG, costs 2. So F and G now need to be unioned together, and they were not in the same set. So I can put those sets together. The next smallest edge is AD. So A to D. So you can see A and D are in different sets. So now I can union these two sets together. So now you can see A, B, C, D, F, and G are in the same set. So A, B, C, D, F, and G in the same set. We're only missing E. So what happens if I try to add CD? So if I try to add CD, you can see that this makes a cycle right here. Using union find, we see that C and D are already in the same set, so I cannot add them. And that's the same case with B and G. If I add B and G, then now I have a cycle inside my graph. And being a minimum spanning tree, you can't have cycles within a tree. So I couldn't add CD, couldn't add B and G, so now I get to DE. Now look here, this is not going to create a cycle, and in my union find, D and E are different sets. So I can union those two sets together, and now I have my minimum spanning tree.